Hey everyone, it is Mr. Vargas here, back again, helping out Math 8 this time on homework 5.6, page 427. Today we are using the Pythagorean Theorem, so we're getting some more practice with that, and we're checking out some real-world examples from your textbook. I did my best to draw a few of these examples out for you. Number one pretty much had like a tree and a cat, or the height of the tree or something like that, but anyways, you could see the distance from here to here. Remember, this is the hypotenuse. That long side is called the hypotenuse, and the other sides are called your legs. So you got leg and leg, and we remember Pythagorean theorem tells us we've got to take a squared plus b squared, and that would be equal to c squared, assuming that you are actually working with a right triangle, and in these cases we are. So let's go ahead and just plug in what we know. We've got a leg, that's 5 squared, okay, plus we don't really know what this is. It's h. The letter really is arbitrary. It doesn't necessarily matter. We'll just keep it as an h. Sure, that's fine. H squared, and that is equal to the square of our hypotenuse, which is 12 squared. Okay, easy work. Let's just go ahead and simplify. 5 squared is 25 plus h squared equals 12 times 12 makes 144. We're going to subtract 25 on both sides, and we get h squared is equal to, let's do some borrowing here, that becomes a 3. We've got 9, 3 minus 2 is 1, and we've got another 1, so h squared is equal to 119. H is not alone yet. We've got to take the square root of both sides, and h is equal to the square root of 119. You could leave it like that, or if you wanted to approximate it using a calculator, you would find that h is approximately 10.91, and this was in feet, I believe. So I'll accept either answer here, circled in red. Fantastic. Let's jump down to number 3. Number 3, they kind of try to throw you off with this one. They give you a pyramid, and they give you a little bit of extra information. I think they tell you that one of the base sides is like 8 centimeters. We're not even going to worry about that. We're just worried about the triangle that's in the middle of that pyramid. So once again, we've got our hypotenuse here. It's our longest side, opposite of the 90-degree angle, and then we've got our legs over here, leg and leg. So let's set up Pythagorean theorem with this information. I've got 11 squared plus 4 squared, and that's going to be equal to this hypotenuse, which is just x. So cx doesn't necessarily matter what letter you're using, it's just representing that hypotenuse. Awesome. Now that we have this, we can simplify and solve for x and find out how long that side is. So this is 121 plus 16 is equal to x squared. Simplifying by adding on the left, you get 137 is equal to x squared. Alright, and then the last step is to take the square root of both sides. So you get x is the square root of 137, or x is approximately, if you want to punch that into a calculator, square root of 137, you will find that x is approximately 11.7 centimeters. Awesome. So either one of those serve to be the correct answer. Okay, last problem for tonight. Let me go ahead and drop down to number 6. This is a little bit of a word problem. Rodrigo is buying a 5.5-foot long fishing rod for his father's birthday. He wants to put it in a box so that his dad will not be able to guess what is in the box? We do know that the box is 4 feet long and 4 feet wide. Will the pole fit in the box? So let's draw a box. Do my best to draw a square. That's good enough for today. It is 4 feet wide and 4 feet long. And pretty much we are trying to figure out if a fishing pole that's 5.5 feet long fits diagonally if we lay it down in the box. Because if we try to lay it up and down, 5.5 feet would already be way too big. Going left and right or sideways or up and down, it would not fit in the box. So we need to lay it at a diagonal to kind of maximize how much space we use. Okay, these do form right triangles here. Remember, boxes or squares have 90-degree angles in each corner. So we can use that information then to figure out what this distance is from one corner to the other. So let's use Pythagorean Theorem. It says a squared plus b squared is equal to c squared. This time we are trying to figure out the hypotenuse from one end to the other, and they give us our legs, which are both 4, leg and leg. Okay, let's plug that in. So we've got 4 squared plus 4 squared is equal to c squared. And then we would get 16 plus 16 is equal to c squared. 32 is equal to c squared. Let's simplify, get that c all by itself. Remember, the square root and the squared cancel out, which is exactly what we want. So you get c is equal to the square root of 32, or c is equal approximately, if we plunge that into a calculator, 5.67, and that would be feet, right? This would be feet. A little sloppy there. Okay, so we know that the fishing rod is 5.5 feet long, and the distance from here to here is actually 5.67 feet. So yeah, that fishing rod will fit. We have enough room to fit a 5.5 foot long fishing rod in that box. So we could say yes, the fishing rod will fit in the box because the hypotenuse created by the right triangle is 5.67 feet long, and the rod is only 5.5 feet long. And that's good enough explanation for that. So that concludes this video. I hope you guys do well in the rest of your assignment, and see you in class.